welcome everybody that's here in the classroom. And I also want to extend a welcome to all those that are tuning in remotely via Zoom, both students, faculty, and then also professionals who are interested in these topics. And so welcome to you all. So today's presentation will come from a couple of different presenters. I'll introduce them now. So Vaughan Andrews is the Senior Manager of Sustainability at Weyerhaeuser. With over 8 years of experience in sustainability and carbon accounting. He oversees carbon accounting programs, including carbon emissions, removals, target progress, and assurance, influences sustainability standards, and integrates all of that into company strategies and reporting. And he leads Weyerhaeuser's climate change ambition with their 3x30 positive impact areas. And so you all will have read about the 3x30 initiatives in your lead up to today's presentations. And then Sarah Fulcher is a senior product manager at Weyerhaeuser with over 17 years of experience in the wood products industry in product management, product development, and strategic planning. She leads development and implementation of the go-to-market strategies for sustainability within wood products business. She leads Weyerhaeuser's Homes ambitions within the 3x30 positive impact areas, and then also helps to support strategic planning and portfolio management across Weyerhaeuser's OSB, softwood lumber, and engineered wood portfolio. And so as we get started, the title, as you see, for today's presentation, A Carbon Story from Forests to Building Products. We're going to be touching on a number of different learning objectives and cutting across Weyerhaeuser's history and their work from forests to wood products to the built environment. So we look forward to the presentation. We thank Sarah for being with us and Vaughan, and we turn it over to you all.
Great. Thank you so much. Can you hear me?
Yes, we can.
Okay. Wonderful. Well, thank you so much for the opportunity today. We're really excited to share the carbon story with all of you. At Weyerhaeuser, we are truly committed to supporting education and innovation that enables sustainable building and the use of wood products to do so. And so we're really excited to share the story at this stage in the seminar series, because we think it's going to be such a great introduction to some topics that the seminar over the next several sessions will be diving into more deeply. Thank you so much for the introductions as well. Along with introducing Vaughan and myself, we'll skip over those. We have a slide of that as well on our screen. What I would like to do, though, is still introduce who we are at Weyerhaeuser before we dive into the carbon story. We will try to take a break midway to ask any questions. We'll be watching the chat or ask for some help to watch the chat. But if we don't get a chance or we're running short on time, we'll try to stick around at the end to answer any questions. And also the team here has our contact information. So if you do have some questions you jotted down, we're happy to follow up with you after the seminar session is complete. So we already touched on the learning objectives. We really are going to start in the forest today, and we're going to bring the theme of carbon through from the forest to the wood products and really into the built environment today. And so to do so, we thought it'd be really nice just to introduce who we are at Weyerhaeuser. Scale means a lot to us. We are the largest REIT, or real estate investment trust. We have over 120 years of experience, both owning and sustainably managing our timberlands. And with that, we also have focus areas both in real estate, energy, and natural resources. And we are a wood products manufacturer as well, with locations all across North America. And then to add to that, we also have a focus on the emerging carbon platform. So with all of this, we really have a tremendous responsibility to be great stewards of the land, our people, and the products that we make. And because of our scale and our stewardship mindset, we have a unique view into all of the steps along the supply and the value chain. Everything from seedlings that grow into trees to the relationships with diverse customers using our products. We're one of the few remaining companies with operations in all of these facets. So when we talked about scale, we are the largest private landowner in North America. And we own about 11 million acres of highly productive forests in the United States. And we also manage about 14 million acres of licensed land in Canada. So I have a question for you. From our timberlands here on the screen, what would you guess our annual harvest rate is? Just jot it down really quickly. 10%, 20%, 50%? It's actually only 2%. We harvest about 2% of our land each year. And you may be wondering, why is that important to highlight? Well, that means that we steward 98% of our living forest in various stages of trees, from seedlings to mature trees creating habitat, all of which are capturing and storing carbon. So we'll come back to why scale matters in a little bit, but for right now, I want to hand it over to Vaughan, who will start us on the carbon story journey.
Thanks, Sarah. So hi, everyone. As was mentioned, I'm a senior manager of sustainability here at Weyerhaeuser. And I spent a lot of my time thinking about how carbon moves throughout our company's ecosystem, whether that's in our forests or in our wood products. And if we advance the slide, I want to introduce you to one of the cooler projects that I've done in my 5 years of time here at Weyerhaeuser, which is something that we call our carbon record. And what we've always sort of known inherently is that carbon has a really important part to play in our company's operations. But we, for the longest time, were having a hard time sort of quantifying what that impact was. And so when we went about thinking what that carbon impact was, we started just with a very simple view here of, as our forests grow, they're absorbing and storing that carbon dioxide outside of the atmosphere. But when we harvest down our trees, we also get the opportunity to have that carbon remain stored for a really long time in the long-lived wood products we make. So think about a house or an apartment building or even a desk that I'm using. That carbon was sequestered by a tree and remains stored out of the atmosphere, which is a really important part of what we do to help contribute to climate change solutions. But not only do those wood products continue to store carbon, but our trees, when we replant after harvest, absorb even more CO2 as they grow. And so it really is this endlessly renewable cycle of a carbon positive story. And when we think about quantifying that on an annual basis, we remove about 3 times as much carbon as we emit throughout all of our operations each year. And just to put that into a little bit of perspective, 31 million metric tons of carbon dioxide equivalent is about the same as removing 7 million cars from the road each year. And I'm based in the Seattle area, and just to put another bit of context on this, that's about twice as many cars that are registered in the entire state of Washington. So a pretty big impact just from the fact of our trees growing and our wood products storing that carbon over the life of their useful life. But then in addition, we also know that our carbon emissions have a really important part to play as well. And if we go to the next slide, I'll talk a little bit about how we quantify those things and what's included. So this is another view of sort of the overall storage of our carbon record. And one of the things I should mention as well is that the reason we call this a carbon record, we're having a little bit of fun with the fact that a record can be something just like a bank statement. It can just be a record or a line item of a bunch of numbers. But what I've also thought is always really cool is if you look at the cross section of a tree, it's called a tree cookie. And each of the little tree rings that are there, to me, have always looked like a record player. And now that records are cool again, we put some fun branding around this project where each of these tracks, each of these categories of our carbon story are one of the tracks on our carbon emissions, on our carbon record. And as we grow, or as the years progress, we're adding more and more tracks to make sure that the record can keep spinning. So if we think about if we think about track one, that's where we're most focused on making deep emissions reductions. Those emissions are everything from the fossil fuels we're using to move our machines around, whether that's in our forests or our wood products plants. And it's also all of the emissions associated with what's called upstream and downstream activities, not just what our company is responsible for, but the larger ecosystem of contractors in our forests, or anytime we sell a product to somebody else, the emissions that they're responsible for are included in that 10 million number. So maybe an easy example that I use is every time a company like Apple, I'll just like pull up my iPhone here, produces an iPhone, their carbon emissions are inclusive of the electricity it takes to use this iPhone. And for a wood product, it's a little bit different because you're not like turning on and off a wood product, but oftentimes there are further steps in the manufacturing process, whether that be making something into a pulp or a paper product, or making something else with a piece of lumber that we've created. All of those emissions are something that we take responsibility for as well. And we've set significant emissions reductions targets to push those closer to zero. You can see that on the right of the slide. But when we think about our timberlands and our wood products as a climate solution, we're really talking about track two, which is our carbon removals. And that's everything that our forests are doing on net to impact the climate. And so it's not just the growth of our timberlands, but it's also the harvest. And one of the really important things we wanted to quantify was our impact of all operations, not just of the good things that we're doing, but really showing that the model of working forestry that Weyerhaeuser practices contributes to climate change by reducing the atmospheric levels of carbon dioxide in the atmosphere. And as noted on the slide, the world needs more of these removals technologies at scale if we're going to combat climate change. The third track is really interesting to me, at least, because it helps put into context, yes, 10 million seems big. That's about that's a certain number of cars being released. Same with 31 million on the carbon removals, but the true scale of Weyerhaeuser is only really evident in track 3, which is the carbon storage that remains stored year over year in our forests. And so if we were to convert all of our forests to an agriculture use or for development, that huge number, the 2.3 to 3.6 billion, would go much closer to zero. And that's the real impact that we have of keeping our forests stored as forests. And to put those numbers into some perspective, that's about equivalent to the energy required to produce all of the energy required for all of the homes in the entire United States for between 3 to 5 years. That's the equivalency of those carbon emissions, and that's what we're storing in our forests. So that's really the introductory view of our carbon record. If we go into the next slide, I'll dig into each of these topics a little bit more, and then I'll make sure to leave some time for questions before we transition over to Sarah. So here we're just highlighting our track 1 and what our carbon emissions are for the last calendar year, for 2022. If you remember when I referenced sort of those upstream and downstream emissions, let's focus just on our own operations, which are what's called scope 1 emissions. That's everything at our manufacturing facilities, the fossil fuels we use, as well as any other sources like refrigerants of greenhouse gas emissions. And that number is just less than 500,000 metric tons. There's also some emissions from the energy that we purchase. So if we're purchasing electricity from a utility that's burning natural gas to create their electricity or is using hydropower, we're taking into account all of those different types of energy depending on where we're using energy. And so some of our manufacturing facilities that are in less carbon intensive areas have a lower what's called scope 2 greenhouse gas emission. And then scope 3 which is much bigger for us, is all of those upstream and downstream products and services. And one of the really important things to know about Scope 3 is that there's this line between Scopes 1 and 3 where our Scope 3 is somebody else's Scope 1. And so there's some double counting that happens in this accounting exercise, where there are two incentives to reduce your Scope 3 emissions. You have your own responsibility to reduce Scope 3, but somebody else is also responsible for making emissions reductions commitments for a lot of those Scope 3 emissions. And so the big example there would be a company like International Paper, for example. We're selling them a lot of our wood fiber so they can make pulp and paper products. And they've set their own emissions reductions targets that are going to help us decrease our Scope 3 number over time. And so there's a little bit of, I'll use the term collective action in terms of Scope 3 and helping everybody across the economy contribute to climate change solutions, as opposed to just putting that onus or that responsibility on a single company. If we could go to the next slide. And here's just like another deeper dive into that Scope 3 category. There's a really fun meme. I forget which TV show it came from, but there's this like crazy looking dude making a bunch of like whiteboard connections with strings and like notepads. And our Scope 3 inventory really began like this with our supply chain teams, just mapping out where all of our products are coming from and where they're going to, and making sure that we could account for the carbon impact of our full operations, not just the subset that we have direct ownership or control over. And so Scope 3 was a really interesting challenge for us, both just from getting a broad understanding of what our biggest sources were, and then also thinking about what our levers of decarbonization are going to be. Which of these hotspots are going to be the easiest or the hardest to decarbonize as we think about some of our plans moving forward? I'll just touch on a few here that I think are pretty interesting. In our forests over on the left side, we have some pretty heavy machinery that's required to cut down trees, to do all of those in-forest harvest activities. And we account for that in our Scope 3 inventory, because a lot of that work is done by other third parties that we're contracting out to. There's a lot of really cool technology, whether that's from using different fuel sources in our forests or thinking about longer term, so electrifying some of those operations to reduce the greenhouse gas impact. It's going to be a little bit easier, or I would say it's going to be more challenging to electrify some of those machines, both because of the size, but also just because of the infrastructure. It's much easier to charge, let's just pick on Tesla. If you're charging at home or at the grocery store, there's charging infrastructure that can get built up around those activities. It's much harder to put that charging infrastructure out in our 11 million acres of timberlands. And so that is a longer term consideration that we're having in terms of our Scope 3 emissions. But I won't focus too much more on Scope 3. I want to make sure we have some good time to talk about our removals as well. So let's move on to the next slide. And when we think about our removals and putting this all in perspective again, those removals really are our net number. And so like I mentioned, as our forests grow, and as Sarah mentioned, we're harvesting just 2% of that each year. And so the other 98% behind me is just growing like it would normally grow, taking in carbon dioxide, putting on mass, and storing that carbon for a really long time. And as we think about the small amount of forests on sort of relative to our whole land base that we're harvesting, that's why that net removal number is so large for us. And it's something that we've been tracking now and reporting on for about 3 or 4 years. And we have some really in-depth methodology that we've shared, and we've gotten some third-party feedback on. And it's one of the things that has really helped us sort of position Weyerhaeuser's viewpoint when we're entering into these carbon conversations. It's like, hey, from a baseline, here's what our removals are, net of all of the emissions that we have, including our harvest activities. And then, like I mentioned, it's that carbon storage number as well, which is so much bigger, that helps really put in perspective. Even though the pluses and minuses can appear important, the real important number is just the amount that's stored in the long term. And then one of the things I always like to close with when we're talking about our carbon story is putting not just our carbon impact, but into perspective, but thinking about that the global challenge of climate change. What we've seen even this summer is a number of impacts. It doesn't matter if you live in Los Angeles or in Seattle, or I think Sarah is based in Phoenix and experienced something like 30 to 40 days of consistent high temperatures of over 110 degrees. Sarah can correct me on the details, but it doesn't matter if you're in the West or if you're in Europe or if you're in other parts of the world. The impacts of climate change are occurring what seems like on a daily basis. And every little bit of carbon emissions reductions that we can make have a big difference, whether that's reducing the number of folks that are exposed to heat waves, whether that's lessening the stress that are on all of the plants and animals in the world, or whether that's thinking about the actual hard dollars that are being lost either to recover from climate disasters or are having to need to be allocated to increase our resiliency. Something I'll just pick on Phoenix and Arizona again, is there's just going to be a lot of sort of new infrastructure that needs to be built to support folks being safe during some of these heat waves. And those are dollars that we'd probably rather spend reducing our greenhouse gas emissions, but because we're doing that too slowly, we're having to contribute more economic dollars to surviving climate change rather than mitigating our impact on it. And so I want to make sure, especially as we're thinking through these conversations as a company, that we're not forgetting the fact that we are in a crisis, and the stuff that we are doing on the ground can help, but we need a lot more. It can't just be us. It needs to be a full economic shift away from a reliance on fossil fuels. And while our impact is large, we always need more help along the way. And so really hoping to have a great conversation today around the benefit that the built environment can have to help contribute to some of those solutions. That's just our piece. So with that, I think we have a few minutes for questions. Would love to get any feedback, either Sarah, if something has cropped up in your mind, or from folks in the room. Happy to answer anything about our carbon accounting or some of the sustainability work that Weyerhaeuser has been doing.
Okay, do we have any questions in the room or on the chat? Yep. Sure.
So I have some question regarding the store carbon. It seems like the estimate is quite a big range, from 2.6 billion to 3.6 billion. So my first question here is, what contribute to the big uncertainty, right? The range in estimating this. And the other kind of second part of the question is, what is it trending? Is it increasing or reducing the storage right now? I understand you keep like 98% unharvested, you only harvest 2%, 98% keep growing. Overall, is that store carbon growing or reducing? Yep. Thank you.
Yeah, absolutely. So I'll answer your questions in order. So the way we think about our carbon storage, let's divide the forest into 3 different pools of carbon. First, you have the live living trees. Then you have all of the other living biomass on land. Think of shrubs or downed wood, and you can kind of see some of the animations. The roots are also included. And then the third category would be the forest soil. And when we think about our certainty around each of those 3 pools, we have really good knowledge and certainty around how much carbon is in our live trees. That's what we're responsible for growing. That's what we're harvesting and need to make business plans around. But then there's less certainty around the other 2 categories, the sort of sort of shrubs and other live elements not part of the tree, and then the forest soil is a big portion of uncertainty. And so what we've put underneath that 2.3 to 3.6 range are three different numbers, not on this slide, but on our full methodology, where we put one number for our live trees and then a range based on literature that's out there, scientific peer-reviewed literature, and US Forest Service data that's helped us estimate the range of those other pools based on how much live tree carbon there is on our land. And so the biggest uncertainty is really coming from that forest soil carbon, where down to a meter of depth, there's a lot of uncertainty depending on your region, depending on the relative moisture rates or the species of trees that are growing. There's a big range of carbon that can be in those soils. And it's something that we're researching and have invested money into, particularly in our western forests, to understand what that carbon pool is. But it's not something we're comfortable putting just like a one number range around. We were more comfortable putting a full range. And then to your second question on, is this number growing or shrinking? It's growing, but it's growing slowly based on those carbon removals you see on the left-hand side. The million is just many orders of magnitude less than the billion. And so the bigger driver of how much carbon is stored is actually how much land we own, as we're transacting either small or medium-sized portions of our land with other landowners, or thinking about what else we could be doing with different portions of our land. It's more about how many acres we have as opposed to what we're doing on the land, because that's the real driver of that number. But if all land remained the same, then it is that carbon removals number that's the change in the storage number. And so it's increasing, but it's increasing slowly.
Okay, thank you. There is a question on the chat, and I'll get to that in just one second. But just for the sake of clarity, and I think our students understand this, but Vaughan, if you could just unpack this unit, metric tons carbon CO2 equivalent. Can you describe what that means, the CO2 equivalent, just for anyone that may not know that?
Absolutely. So there is a lot to unpack within those 6 symbols, I suppose. So let's start with just carbon dioxide. As we burn fossil fuels, some amount of stored carbon that's like a one carbon molecule binds with oxygen in the air and releases as a gas carbon dioxide. And that's one of many gases that have a heating effect on the world, which is causing global warming. And so the E is actually some, I would say, simplification that allows us to put one number on our impact as opposed to 3 or 6. And by 3 or 6, there's different gases: methane gas, nitrous oxide, some refrigerants that are all sort of underneath the E. But what the E does is it like brings everything together into a common unit so that you can more easily communicate this information. And then the MT stands for metric tons. And so that's just an amount of that gas. And the real operative unit there is carbon dioxide, with the other letters being a little bit of simplification to help us communicate this more easily.
Okay, great. And then the question from the chat asks, how do you track your upstream and downstream emission? What is the cost of doing that? Yeah,
great question. So when we started this in 2020, so almost 3 or 4 years ago, we were using what's called industry estimates, essentially, where on average, we knew how much carbon emissions were coming from a pulp and paper plant, but we weren't going to each one of our customers and asking them and getting a specific data point for what their emissions were from the wood that we were selling them. And so at first, we were getting most of this either from large industry estimates or from third-party data sets that gave us a rough view into what our scope 3 upstream and downstream emissions were. Over the last 3 years, we've spent, I would say, on average, 10% of my time is spent in conversation with some of those customers and suppliers to help get more specific figures related to those emissions factors. And so we start with the big customers, such as an International Paper, or some of the big suppliers, such as some of our bigger like shipping partners, especially in the trucking or in the rail business, that are helping us. And they're also thinking about this scope 3 challenge, right? And so they're being asked by many people to provide data points, just like we're providing data points to many of our customers to help them develop their own scope 3 inventories. And so it's every company right now that's having to grapple with some of these conversations. There are regulations and frameworks that are in development that are sort of causing a lot of other people to think about this as well. We haven't sort of put like a specific monetary cost to this yet, because that's going to come when we think about actually how to decarbonize. But just from a data perspective, it's time and it's effort, but it's not insurmountable, and it's something that we're having a lot of help with, because we're not the only ones thinking about this challenge.
Okay, thank you, Vaughan.
Absolutely.
Why don't we go ahead and we want to leave Sarah plenty of time as we kind of turn the page here to the built environment and forest products. So Sarah, why don't you jump in here?
Yeah, you bet. Thanks. So we're going to transition from talking about the forest and the trees and the storage carbon benefits that our trees are providing us into the actual wood products that we produce. And there are other producers, of course, of wood products in the industry. But one of the things I think might be helpful just for context of the conversation that we're having here today is around what do we mean when we say wood products? Here on the screen is a very high level view of the 4 product categories that we think of as wood products. This is really focused on the structural wood products. There are many ways that wood products show up in the built environment. But for the theme of today and for focusing on the positive impact that in the built environment, we're going to stay somewhat focused on the structural type of products. So we've got lumber and panels like OSB and plywood. Those are probably familiar to most of us here today. Engineered wood also, so that would be your glue-lams or your LVLs or laminated veneer lumbers. Those are also wood products that are used structurally today. And maybe the newcomer on the scene, at least for us here in North America, is mass timber. We've been building with heavy timber for decades now, but mass timber is relatively new. And mass timber is not only a product, but it's a construction type, construction method that we'll come back to here in a little bit. The good news is that all of these products store carbon. And when produced and sourced responsibly, all of them have lower embodied carbon than alternative scope 3s, than some of the alternatives that you probably could think of today, like concrete and steel. So earlier I mentioned we come back to the concept of scale, and here's a view of our operations in wood products. So this is the Timberlands map that I showed earlier about our land base that we own and manage. And overlaid on top of that is our distribution and manufacturing locations. And what you can see here is that we produce wood products near the forest, near where the trees grow. And then we have a distribution network all through North America that allows our products not only to get to market, but also try to get to market as efficiently as possible. So the efficiency in the supply channel is really important when we're trying to mitigate the embodied carbon required for these products. And that applies also upstream, as Vaughan already described about our operations, not only to harvest the log, but to make wood products out of that log. It's really critical that we are being as efficient and as mindful and responsible through this whole process, so the benefits of the wood products are really realized. We talked a little bit earlier, Vaughan mentioned our greenhouse gas emissions. We do have a target to align with keeping with global warming about 1.5 degrees Celsius. And we also use all of our low value residuals. So I want you guys to think about sawdust and bark to generate our own renewable energy. We take great pride in making sure that we use as much of the log as possible. The last thing I'll mention here is that all of our mills are certified to SFI forest fiber sourcing and certified source standard, and select mills are also certified to a chain of custody standard. You may be wondering, well, why mention that? Well, the carbon story and everything we just spoke about, the carbon storage, all those benefits that a wood product could offer would fall apart if the product is sourced from deforestation practices. So as we think about how we use our wood products today, let's think about where they go. Today, in residential construction, so single family, attached and detached homes, about 94% are built from wood in the United States. And when we think about apartments and condominiums or multifamily, about 70% are framed with wood. That's great. That still leaves some opportunity in multifamily. And we know that there's housing in demand. Freddie Mac has a statistic that there's about 4 million housing units in demand that we aren't able to build fast enough. But we build more than houses every year, right? So let's step back and think about the entire built environment. If we're going to solve some of the world's most pressing challenges like climate change we already spoke about, or sustainable housing, we have to think at scale. Research suggests that global construction is estimated to expand by 50% by 2050. And often a building's highest contribution to greenhouse gas emissions is to the manufacturing of the products used to build it and the construction process itself. This creates the greatest opportunity for wood products to have a positive impact in the built environment, where it can replace higher embodied carbon construction methods. So that opportunity exists in a lot of typologies. I'd like you guys to think about commercial or educational or hospitality. The question is, where can wood play a role where it's not the primary construction method today? So we got to think creatively. Through education, like seminars like this today, thinking through what are the possible innovations of existing products used in new ways, wood products can provide a solution for many of the buildings we live and work in. And look at what we can do. The building on the left is Brock Commons at University of British Columbia in Vancouver, BC. And the building on the right is a civic building in North Vancouver, British Columbia. In looking at the opportunities for wood products, we really want to focus on growing utilization of wood to continue the carbon storage and to continue the carbon story. Construction methods and products like mass timber that we briefly touched on earlier are still pretty early here in North America. But what's important to really remember about that is the potential scale for positive impact in products like that or other construction methods that we might innovate in the future are just too big to ignore. It is really exciting to think about what's possible. Creative thinking, innovation, and wood-based construction can play a really critical role in the built environment. As we wrap up our session today, we want to leave you with a question. So to kind of take with you through the balance of the seminar. What role will you play in continuing the carbon story? Vaughan and I, we hope we really have inspired you to dive into these topics today. We have, I think, a little bit of time still, so we're happy to answer any questions. We can step back and go back to the carbon story, or we're happy to answer questions about Weyerhaeuser or anything that I just covered here about the built environment.
Okay, thank you, Sarah. So yeah, let's open things up for questions. What questions do we have from our audience? Yeah. Here we go.
Thank you. In addition to trees, are there any other means of draining the atmosphere of the CO2? seems to me that we're draining the ocean with a straw. So are there any other mechanized mechanisms to extract the CO2 from the atmosphere? Thank you.
Yeah, that's
Vaughan,
a good question. I'm happy to take a first stab at that. When we think about, I mean, let's start with just Weyerhaeuser's point of view and acknowledge where we're coming from. At the scale at which we need solutions today, there's no better alternative that exists as a compared to trees and other natural ecosystems sequestering carbon dioxide and storing it over the long term. We absolutely need to be considering other options, such as more, as you said, mechanistic or technological solutions, such as direct air capture or other ways of removing carbon dioxide from the atmosphere permanently. But we just don't see that at scale today in an economic way that makes sense, nor do we really see the gains that we've needed to see over the last 10 or 20 years since we've been investing in this technology to really believe that it's a solution that can contribute in the next 10 or 20 years to mitigating climate change. And so when we think about options that exist today, we do think that forests are one of the primary options we have to be removing carbon dioxide. But I don't want the emission story to get lost either, in that the real way to solve climate change is not to remove all of our emissions, it's to stop emitting and to reduce those emissions drastically over the next 10 and 20 years. And just because we're removing carbon dioxide doesn't give us or any other company license to continue emitting. We still need to be making those deep emissions reductions. And that's what we're focused on, really as a complementary solution to our forests, not in addition to.
Great. Yeah, thank you for that answer and a great question as well. The other thing that I would point folks to, in case you're interested, I say this just because we're kind of knee deep in it right now, but Professor Stoner and I, Professor Peng, and several other collaborators from Clemson's Wood Institute are involved with research on a project that is sponsored by the Department of Energy through its ARPA-E program, which stands for the Advanced Research Projects Agency, with a focus on engineering. And there's a program within that called HESTIA. I know this is like a million different names and letters, and I can't remember exactly what HESTIA stands for, but you can look that up, HESTIA. And if you're interested, that program is really aimed at carbon removal, carbon sequestration strategies within the building sector. And so that includes, of course, timber solutions, as well as solutions from other parts of the industry, including alternatives to traditional cements, et cetera, other things that are kind of pulling carbon from the atmosphere. So that's a really interesting program and something that our federal government is really targeting through these research initiatives. What other questions do we have? Yes.
I noticed on one of the slides, it talked about burning biomass for electricity. What are the issues that come around with that, I guess, with air quality? And how do you guys mitigate that?
Yeah, great question. So I'll start from sort of the highest level here, which I think comes from a sort of just energy perspective on what it takes to run a big manufacturing plant, which it turns out is a lot of electricity or energy. And so for what we can use electricity for, we do. And that's because it comes from sort of existing sources and it's our cheapest source of energy. But there are also different ways that we need to use heat in our manufacturing processes. And the biggest example there would be in many of our lumber mills, our customers need dry lumber, which has as little water in it as possible in order to make products and homes that are really safe and really secure and be able to move those products around. But to dry that lumber, trees are actually 50% water. And to remove all of that water takes a decent amount of heat just to make that water evaporate, so that the lumber that remains has a really low moisture percentage. But to do that requires heat. And what we use primarily to do that and to create the heat are the sort of biomass residuals that fall to the shop floor. Imagine you have a circular tree that goes in and you're coming out with rectangular pieces of lumber. There are unavoidably going to be some either pieces of bark or residuals that fall to the floor, that would otherwise just get disposed of or would have a really hard time finding a home in a useful product. And so we're able to use those and burn them for heat in order to dry our lumber. And that would be in opposition to, if we weren't going to use biomass, we would use a fossil fuel such as natural gas or some other heat producing fossil fuel. And so when we're just comparing sort of biomass to fossil fuels, both from a greenhouse gas perspective and then also from a pollution perspective, biomass is going to win out 9 out of 10 times in terms of what those pollutants that are coming from our mills are. But then particularly on the pollution side, we have really strict requirements that we need to hit from the Environmental Protection Agency in terms of those particulate matter that are emanating from our mills and then going into the communities or the operations that surround our mills. And to mitigate those, we install different either cleaning mechanisms or filtration systems that remove the worst of those particulates before it releases to the atmosphere. And so those are some of the ways that we're thinking about reducing our environmental impact, not just from a greenhouse gas emission side, but also from sort of air particulate matter side as well. So hope that answered the question. I took that a little more broadly than I think was intended, but hopefully it helped give a sense of why we do what we do.
Yeah, thank you. That was a great question. Any other questions from our audience, whether here in the room or online? No, well, I have one for Sarah. So on the wood product side of things and thinking about Weyerhaeuser and as a company and its history, what in the wood products realm does Weyerhaeuser specialize in? What sorts of products?
Absolutely.
Yeah, go ahead.
Oh no, go ahead.
And then I was going to say, and are there other kind of categories of wood products that Weyerhaeuser is less involved with?
There are. I'm going to go back if if PowerPoint will allow me to, and just briefly talk about these categories, and touch on also the categories that we aren't maybe participate in. So we are the second largest lumber producer in North America, and within lumber we have a specialty around drying. We have a lot of drying expertise. So what Vaughan was mentioning earlier around the moisture content in your wood products, that's something that you really want to be able to manage effectively for various reasons, but one of which is that dimensional stability. You would like that product to stay the same size, thickness, length, not only when it's manufactured, but through the whole supply channel and into the final use and application that it will be in. So say your kitchen walls, where you would like really straight walls. So when you hang your cabinets and your cupboards and you put your nice subway tile, things are nice and straight and they look even and plumb. And in lumber, we have a lot of expertise in drying. And we also have an offering that gives customers an alternative, good, better, best when it comes to the lumber options that they have on the market. Lumber is a commodity product, but there are ways to create value within that space, and that's where drying and our expertise really excels in there. We also focus on structural panels. So we have both OSB and plywood. OSB as an industry makes up about 65% of the structural panel market in North America. And we have 6 mills. We're the 4th or 5th largest producer of OSB. And we also have plywood. And we do plywood kind of in two ways. We have your commodity plywood that you might find if you're doing a DIY project at Home Depot. And we also do very high-end plywood used for concrete forming and reuse applications like that, marine applications. And then in engineered wood, we are the proud owners of the Trust Joist brand, proud stewards of the brand, who originally invented the I-joist and also produced laminated veneer lumber and LSL. We invented laminated strand lumber, which we call timber strand. And we also have a proprietary engineered lumber product called Paralam, or parallel strand lumber. And all of those products together act as a system. They provide some uniformity and some consistency that products like lumber or heavy timber sometimes have some challenges. And so this creates a great alternative for that. You're going to find all of those products in single family homes across the US and Canada. You'll also find them in multifamily, particularly those multifamily units that you'll see that are maybe 5 stories of light frame construction over maybe a story or 2 of post-tension deck. And then we also produce MDF, so medium density fiberboard. Medium density fiberboard, or MDF, goes into various products, often not structural. So you'll see them in cabinets, trim, countertops, children's toys, things like that. And then we also have these products go into industrial applications. So think of millwork, doors, residential and commercial doors, and furniture, upholstered furniture. There's a lot of applications for our products. Even though we are focused on the structural wood products, we do have products that go into non-structural applications that are all throughout our homes. And then in mass timber, so we are not a producer of the mass timber products that you may be thinking of today, which would be glulam, beams and columns, or CLT panels. However, we do supply lumber, which is the primary component that does go into CLT panels. And we do partner with CLT producers to understand their needs. And one of those is really about drawing. So there's a really nice connection there in our capabilities and expertise and the needs of the mass timber industry as it continues to learn and develop.
Okay, thanks, Sarah.
Yeah, absolutely. I want to make sure I answered your question.
We've got maybe another couple minutes, for maybe one last question. Yeah.
Hi. I was wondering like what type of philanthropic projects and grassroots projects that y'all support through like the 3x30.
It's a great question, Vaughan. I'm not sure where we should all start because there's so much. I'm wondering if we could do a little bit in climate, and then I'm happy to help also in sustainable homes.
Yeah, absolutely. So I'll just start with a little bit of context on how we've thought about this in the past and some of the ways that 3x30 has helped us sort of evolve our thinking and some of the new projects that we're doing. So for a long time, we've contributed at the grassroots level to our operating areas, and we have individual giving fund committees in each of our each of the locations where we have either a manufacturing facility or forest lands. And the folks on the ground are really helping direct the company's dollars to the projects that they feel are going to be most effective for each individual area. So it's not a decision that someone like Sarah or I would be making in more of our sort of corporate offices in terms of where we're directing money at the local level. But we also know that there are a lot of other partners in this work that are interested in finding collaborative solutions to things like climate change or sustainable homes or thriving rural communities. And so from a 3x30 perspective, what we've been focused on is identifying who those partners are and making sure we're designing programs that are going to be most effective for everyone involved. And so on the climate perspective, we're partnering with many different universities. I would call out Michigan State University in particular, who's been doing some really good work around sort of forest carbon and thinking about that work. Clemson is another example where we've made sure to develop good partnerships with either with different schools or research projects to help make sure we're learning more about the carbon impact of the built environment, and that we're headed in the right direction. I also know that we have some really exciting work planned in our rural communities action area that's actually going to be made public in the next few weeks here, and so I'm hoping that we'll be able to pass along some resources to show that once that is available. But there's also some really exciting stuff that Sarah might be able to talk about in our homes challenge area as well.
Yeah, absolutely. And this topic today really has a really strong connection to our sustainable homes ambitions. So within sustainable homes, we have two main focus areas. The first is really focused on supporting the education and the innovation for wood innovation, to make sure that wood products continue to be at the forefront of supporting building more housing. And I use that word intentionally versus homes. A lot of people think when we say homes, we mean single family homes that might pop to mind. So for us, it's really about housing and really helping address the housing gap that I referenced earlier, and doing it in a sustainable way and ideally built with using wood products. So this seminar really touches on that, but we also support both academic and philanthropic organizations that focus in that space. And so one that I'll call to mind is Ivory Innovations. We are a founding partner for them, and they are connected to the University of Utah. However, they reach out much more broadly than that. They do events such as Hack a House, and that challenge is coming up here shortly. And then they also work in the policy space. And so that's something that we love to support, is helping continue the conversation about not only more housing, but doing it in a sustainable way through policy. The other focus area that we have is around supporting in the industry around unconventional and maybe non-traditional housing. So think of things like tiny homes. We partner with Operation Tiny Home over the last few years to support their programming. And we now have a corporate sponsorship with Habitat for Humanity. And we are just about to launch a innovation challenge with Habitat and their affiliate locations to innovate their processes and the products that they use to help build more houses more quickly. So those are two things we're really excited about. And then we also continue to support efforts around mass timber and support its adoption in the industry and through policy and through education. And you can see the connection hopefully through rural communities. So where do we need the housing? We need it everywhere. We need it where we operate as an organization in our rural communities, and we also need it in urban areas. And so there's just not one solution for everyone. But that's what's so exciting about our 3x30 ambitions, is being able to make an impact across all of the different communities that we operate in. So hopefully that helped. Vaughan, did I forget anything in 3x30?
No, I think that covered it pretty nicely.
Okay, thank you both. So join me in thanking our presenters. I really appreciate their time.